the Trig team. Is this what I think it is?
I think it is. I think it's a unit circle.
Well, how are we going to solve it?
I think I know how.
The unit circle exists on the coordinate plane of x and y. It is a circle with a radius of 1 and an origin of 0, 0. There are 4 quadrants in the unit circle. However, we're only going to be deriving the first quadrant and showing how it applies to all 4 quadrants in the unit circle. But before we do anything, we have to list all the radian values and all the degree values in the entire unit circle, so let's do that first. Those are all of the values in the unit circle, radians and degrees, and what you'll notice is that this value right here, 2 pi, is actually the circumference of the entire unit circle, 2 pi radians, and it exists at 360 degrees. Now the cool thing about this is that both 0 degrees and 0 radians and 360 degrees and 2 pi both have the same coordinate point, which we'll get to later. So before we get to that, we're going to derive all of the points in the first quadrant. So let's get started. The angle we are going to start with in this derivation is the 30-degree angle, or pi over 6. Now, in order to figure out what this point is right here, we are going to need to use special triangles. And the specific special triangle we're going to be using is a 30-degree, 60-degree, 90-degree triangle. Now, you may be wondering, how are we going to do this? Well, the first thing we're going to do is drop a line right about here. And this is going to create our triangle, because it creates a 90-degree angle right here, and we have 30 degrees, 90 degrees, and 60 degrees, 30, 60, 90. Now, what we know about this triangle already is that because the radius of the unit circle is always 1, our hypotenuse is going to be 1. We also know that this side length is going to be y, and that this side length is going to be x. So now that we know all of these things, we can figure out what y is and also what x is. But in order to do that, we need to know what the normal side lengths for a 30, 60, 90 triangle are. So if you look at a basic 30, 60, 90 triangle, you'll see that the hypotenuse is 2, the side length is 1, and the other side length is the square root of 3. Now, if you look at a normal 30, 60, 90 triangle, you'll see that the hypotenuse is 2, the side opposite 30 degrees is 1, and the side opposite 60 degrees is the square root of 30. However, we're dealing with a 30, 60, 90 with a hypotenuse of 1, because the radius is 1. Therefore, we need to cut this side length in half, because 1 is half of 2, which means that this side length right here is going to become 1 half. And we can use this side length 1 half right here to determine this side length, the square root of 3 side length. And all we have to do to figure that out is multiply 1 half by the square root of 3 over 1. The 1's cancel out, and you get the side length of 3, square root of 3 over 2. Now you can plug this in right here, and we've just found our side length. And since we know that x is this side and y is that side, we can now conclude that y equals 1 half and x equals square root of 3 over 2. So now we have our side lengths. However, we can't just find the side lengths of this triangle. We also have to find the sine, cosine, and tangent of pi over 6. Now, for any angle in this unit circle, we're just going to call this angle theta, we have opposite over hypotenuse. Hypotenuse is always going to be 1, since the radius will always be 1. So that will be our hypotenuse value. And our opposite angle will always be y. And y over 1 will just equal y. So basically, the value of sine of theta is going to be y. So sine is our y value. And cosine is very similar. We have adjacent over hypotenuse. And we all know that 1 is our hypotenuse again, and x is our adjacent side. X over 1 equals x. So cosine is the x value, sine is the y value. And what is tangent? The tangent of theta is the opposite over adjacent, which is just y over x. Pretty simple. So now that we have all of these values, we can now find the sine of pi over 6 and the cosine of pi over 6 as well as the tangent. Let's start with the sine. So the sine of pi over 6 equals the opposite side, or 1 half, over 1, which is just 1 half. which equals y. So our y value is 1/2. We can go ahead and write that in. And our cosine of pi over 6 equals square root of 3 over 2 over 1, which means that it's just square root of 3 over 2, which means it's just square root of 3 over 2, which is equal to x, which means our x value is square root of 3 over 2. So we can write that in here as well. The tangent of pi over 6 is, as we said before, y over x, which is going to give us this super funky looking fraction over fraction. Now this is easy. What you do is you cross out these 2's and you get 1 over the square root of 3. Now this is the wrong way to look at it because you can't have a radical on the bottom. So what we're going to do is pull this 1 over square root of 3 over here, and we're going to multiply this fraction by square root of 3 over square root of 3. And what you get is the square root of 3 over 3. So this is our tangent. The tangent of pi over 6 equals the square root of 3 over 3. So these are our sine, cosine, and tangent values for pi over 6, and we now have our coordinate point. So now that we have all of that, it's time to move on to our 45-degree angle, which is pi over 4. So let's go ahead and get started with that one. Now, in order to find this point right here, we're going to need to use, again, special triangles. But in this case, we're going to be using a 45, 45, 90 triangle. This triangle is a bit different, and you'll see why in a second. So the first thing that we're going to do is drop the line down again. We did this in the other one, and we're doing it again to form a 90-degree angle. And now we have 45 degrees, 45 degrees, and 90 degrees. And what you will notice right here is that these two angles are the same, which means that these two side lengths are going to be the same. So y and x are going to be equal to each other. Now, in order to find these two values, or in this case one value, we need to use the Pythagorean theorem in this case. It's not as easy as the other one. Now, what we do know about this triangle already is that the hypotenuse is 1, because the radius is 1. But now we need to figure out the side values. So let's put x squared right here plus x squared, because these two are both equal to each other, so we can have two x's. Now, all we have to do is combine the two x's and go from there. Alright, so the final value that you come out with is x equals the square root of 2 over 2. And this is both the y value and the x value. So it's both. Now what we can do is do the sine, cosine, and tangent of 45 degrees, or pi over 4. So now that we know the coordinate point for pi over 4, we are done with this angle, and we can now move on to 60 degrees, or pi over 3. Now, we're going to do basically the same process that we did to find the other two angles and their coordinates. As you can see, we're going to be finding this point right here. And in order to do that, we're going to do the exact same thing we did before, drop a line right down here to form a 90-degree angle. And what you'll notice is that we have 60 degrees and 90 degrees. This angle is 30 degrees, 30, 60, 90. And this should look similar to you, because we had a 30, 60, 90 triangle with our 30-degree angle, or pi over 6 angle, which means that this is the reverse of the 30-degree angle. And because it's the reverse, we know that the x and the y values, or the sine and the cosine, are switched with each other. What we knew about the 30-degree angle is that x equals square root of 3 over 2, and y equals 1/2. These two are going to switch. Now our y value equals square root of 3 over 2, and our x value equals 1/2. So our values have reversed with each other. So now we can do the sine and the cosine. So now that we have all of these values and we know the coordinate point, we now have derived the first quadrant of the unit circle, and now we can show how it applies to the rest of the unit circle. So let's get right into that. So now that we've derived the entire first quadrant right here, we can now go in and show how it applies to the second, third, and fourth quadrant. And what we do know is that everything we just did in this first quadrant can be used for every other quadrant in the unit circle, which is pretty cool. The one thing that changes about all of these different coordinates is that the sign changes, and not the sine, cosine, tangent, not that sign, the SIGN sign. So this sign actually changes. And I'm going to show you in a way to remember how it changes. In the first quadrant, all of the coordinates are positive. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. So now that we know this, we can add negatives where they need to be in the different quadrants. And we have figured out the coordinates for the entire unit circle. And now the last thing we need to do is fill out the quadrantals, which are the angles that can't be figured out with the special triangles. And the interesting thing is that the tangent here and the tangent here are both undefined. And that is the unit circle.
It's Mathmaniac.
Should have known. We've been chasing her for 15 years.
Now we finally found her. No longer will the unit circle be used against us. Come on, let's go find her.
All right.